number 2.5 and 2.6 together, fifth and sixth problem. So 2.5 was we had a ring, okay, we had a ring of radius r. You have to find electric field, okay, not potential, electric field at a distance z above the center of the ring. That ring contains that ring carries uniform line charge lambda. You have to find electric field at this point. Then what we have taken, any idea? We have taken one elementary charge dq, right, and we have written that one as lambda into dl. We have written that one as lambda into dl. So suppose this is the origin. So then look at here. So this is actually source point, am I right? Whatever, we don't have to worry about that one. We can just evaluate that one. So this is your italic r, isn't it? This is your italic r vector, am I right? So now let me write this one as dE. So this is theta, then this should be theta. Now dE cos theta will contribute. If you have to integrate dE cos theta, we have done this one, am I right? We have done this one, dE cos theta. dE sin theta, horizontal component will cancel with other element here, isn't it? All horizontal components will get cancelled, only vertical components will get added. What is that dE? Magnitude. Yeah, speak out. Lambda dl divided by italic r, am I right? What is italic r? Root of z square plus r square, both are constant, z and r are constant, isn't it? Yeah, speak out. So now you have to write dE cos theta. What is that one? dE cos theta is a vertical component, am I right? This is dE cos theta. This dE sin theta component will get cancelled with other element here, am I right? If I take similar element exactly opposite, it will produce dE cos theta here, dE sin theta here. Those horizontal component will get cancelled. We have done this problem. Just look at that one, and we have to integrate this one, isn't it? So that's your net electric field. Obviously, it is along z cap. Okay, vertical components are getting added. It is along z cap. That's what we have done. Okay. So it's not potential, isn't it? R square, z square. Speak out. Z square plus R square. Is that okay? Italic r square is equal to z square plus r square. So now lambda by 4 phi epsilon naught 1 by z square plus r square cos theta. Theta is also constant. Cos theta also I can take outside. Integral of dl. Am I right? Lambda by 4 phi epsilon naught. What is cos theta? Z by r. Z by r means root of z square plus r square. Z by italic r. Am I right? So z square plus r square raised to 3 by 2 into 2 pi r. Am I right? 2 pi r. That is the integration of dl. dl. When you integrate throughout that one, you will get that one. Is that okay? Yeah. Any question? Now your electric field was, yeah, let me write it down. 1 by 4 phi epsilon naught. Okay, 1 by 4 phi epsilon naught. So z by z square plus r square raised to 3 by 2 into lambda into 2 pi r. What is this lambda into 2 pi r? Any idea? Total charge on the whole ring, am I right? So that's the total charge on the whole ring. Again, along z cap. Am I right? So can I write it like this? Is that okay? That is total charge. I better to write like this. 1 by 4 phi epsilon naught. Z by z square plus r square raised to 3 by 2 into q z cap. Okay, where q is equal to lambda into 2 pi r, total charge on the ring. Next one. Now let me go to disk. Disk of radius capital R. Disk of radius capital R. Is that okay? Now what is the idea? Let me divide the disk into rings. Is it okay? Let me divide the disk into ring, and again the question is, what is the electric field at a distance z above the center? Okay, we have done already using our coordinate geometry, and better to use that one. If you want to do it directly, better to go for that one. Okay, I want to handle some other problem. Is it okay? Which are too difficult in coordinate geometry and in integration. Okay, that's why I'm again. So for this particular problem, you better go for coordinate geometry. Am I right? We have defined dA vector in a plane polar coordinate, and we defined electric field, and again vertical components are getting added. Am I right? The same idea. I have done that one for a disk. Okay. So now what I do here is, I'm not going to do in an earlier way. I'm going to do in a new way. So that is by dividing this one into a ring of radius smaller. Dividing disk into a ring of radius smaller. Is that okay? Now let me take that ring is of radius r to r plus dr. Okay. I better to take it like this. Is that okay? This ring is of radius r to, this is dr. Okay. R to r plus dr. So now he mentioned for a disk. This is the next problem. Okay. This is I think this is 2.4. Yeah, this is 2.5. This is 2.6. Okay. Fifth problem. This is sixth problem. Okay. Extension of this one. So this is what he has done. Okay. This is what he has done. dr, isn't it? Then now what is the net charge on this one? Any idea? Sigma is the surface charge density. What is the net charge on that one? Because to write this formula, I need net charge on the ring. Am I right? What is the net charge on that one? And I'm going to call this net charge on this one as dq. Net charge on the whole ring as dq. Because now that ring is an elementary one for the whole disk. Is that okay? And I'm going to write the electric field due to this ring. I'll call it as dE. Find the difference from this one. Is that okay? I'm going to write whole charge on the ring as dq, and I'm going to write electric field due to this whole ring as dE, because that is elementary now. For a disk, that is elementary. Is that okay? Just like for a ring, this was elementary. Am I right? I'm just imagining that it is composed of this kind of ring. Is that okay? Now dE is equal to 1 by 4 pi epsilon naught z. Again, this distance is same. Z square plus r square whole power 3 by 2 into q. In place of q, let me put dq z cap. Is that okay? Now I have to integrate that one. I have to integrate that one. So how should I integrate? Wait a second. Now you have to write dq properly while integrating with respect to r. Am I right? You can see that one, integration with respect to r. Where does that r come? You have dq. So now writing that dq is the main step. Okay. Now look at here. In plane polar coordinates, suppose you have concentric circles of inner radius r, outer radius r plus dr. What is the area? What is the area? You have taken this idea. No, area of this one. I need charge on this ring. Okay. So again, sigma is dq by dA. Am I right? If I know the area of the ring, then I can find charge on the ring. Yeah. Why you are saying pi r square? No, not total area. I'm talking about area of the ring. Area. Why are you subtracting? Why can't you do 2 pi r into dr? Extend it, isn't it? I think you, whatever you said, it will get the same answer. No? 2 pi r into dr. Am I right? 2 pi r is the circumference extended in all directions. We have taken this idea while doing some density of state problem. Do you remember? We have taken this idea while doing density of state problem. Just see that one, okay, today only. just go back and try to grab these ideas, coordinate geometry, isn't it? 2 pi r is the circumference of the inner one, so dr extended, that's your area, okay? So that's why this dq I can write it as sigma into dA. dA means total area of the ring, okay? So that is sigma into 2 pi r into dr. I should have drawn it like this actually. I should have drawn that ring like this. Is that okay? So once you substitute, you are ready to integrate. Now I'll take magnitude and I'll integrate, okay? Anyway, all of those rings will produce the electric field along z cap direction only. It will add up. Is that okay? So now electric field will be 1 by 4 pi epsilon naught. So z dq is 2 pi r dr, sigma into 2 pi outside. Is that okay? Integral of r dr divided by z square plus r square raised to 3 by 2, 0 to capital R. Check it out. Sigma 2 pi r z, yeah, that's correct. Along z cap, that's a different story. Okay, along z cap. Yeah, what is this one? This is electric field due to a ring, okay? Ring of radius r. But the charge of the ring, I have written it as elementary. Why? For a disk, that is elementary. For a disk, that ring is elementary. Okay? And we have to add that. Yeah. 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 So this is area of the ring actually. Area swept by the ring. Ring will have inner radius r, outer radius r plus dr. That's what I have assumed. So from here to here, you had your answer in line charge. Am I right? You have to convert that one. You have to somehow relate that one to surface charge. So that is the main task here. Which one? This dq. No, this dq is due to total ring. That's what I'm saying. dE? Yeah, dE is also due to total ring. That's what I'm saying. That's why I just copied this one. Isn't it? This dE, that is due to ring, remember. This is due to total ring. I just copied this one from here. No, this whole, that last answer was due to total ring. Am I right? Yeah, I mean here we neglect that thickness, but here you have to take that one. Otherwise, you can't relate this one to surface charge density. If it is elementary, it should have some surface. Am I right? So on a surface, if you are doing the integral on the surface, means you should have elementary surface, and that ring is my elementary surface. Is that okay? You will get the same answer as before. We haven't used this kind of technique. What we have done, we purely use coordinate geometry. Is that it? We have taken vertical component and we integrated with respect to theta as well as r as well as theta, isn't it? In a plane polar coordinate. That is the best idea. But I need this idea to extend it. Okay, that's it. Is that okay? So this dE, that is due to one ring, one elementary ring. That elementary ring have got this much area. That's what I'm assuming. Okay. So that's why charge on that ring is dq. So electric field due to ring at a distance z, if charge is q, in place of q I put dq. Is that okay? So total charge on the ring is dq. Okay. So now once you can just, I think you will get the answer. You will get whatever you got the earlier. Or just see the earlier integral. You might have got the same integral, obviously. Just see that one. Earlier integral. Just see earlier integral. You might have got same integral. And integral of d theta, you will get 2 pi. 2 pi already comes here. So since it is only ring, you have to take ring of small radius r equal to 0 to capital R. That will sweep the whole thing. You don't have to take theta integral, okay? It's already, theta integral is already in the ring, am I right? Now you have to run the ring radius from 0 to capital R. That will sweep entire disk. Yeah. This one. I have taken the ring here. Is that okay? This is the ring answer. Is that okay? So now here ring is elementary, part of that one. That's why I have taken D. Is that okay? So now I'm just putting the same answer here. Same answer as that I got here. But in place of Q, I put DQ because this ring is will not contain total charge of the disk. This ring contains a part of the charge. That's why I'm putting it as DQ. Fraction of the charge. Is that okay? So now how to write this DQ in terms of sigma dr like that, isn't it? So that's why you have to go to that idea. You have to imagine that ring have got inner radius r, outer radius r plus dr. That's why I have taken this thickness as dr. Is that okay? So then, so charge on the ring, that should be related to surface charge because now it is a surface charge distribution. Is that okay? So now once you write, now the total charge on the ring, the total charge, okay, not only here. I'm talking about total charge on the ring is equal to surface charge density into fractional area, isn't it, of the ring, area of the ring. So that is 2 pi r into dr. So that's how I just imagined like this. I just imagine a ring like this. Is that okay? This surface area is 2 pi r into dr. Is that okay? So that's how that dr comes here. You can do r integral 0 to capital R. You will get the answer. I think you might have got same integral earlier, isn't it? You will get the same answer. Is that okay? Let me just stop it here because I needed just that idea. That's it. Now look at here. You can extend this one to find last answer. It will depend on Z. Am I right? You can extend this one to find electric field due to finite cylinder, isn't it? Are you getting my point? Electric field due to finite cylinder. So I think he said, he asked us to find that one in a different way. Yeah, anyway, we shall do that. Okay. Yeah. Yeah, there I had taken surface area like this, okay. This was elementary area and we put that dA as r dr d theta and charge dq. But now I am making that one elementary as a whole ring as elementary. I am taking whole ring as elementary. I am taking answer of the ring. So there we have taken the electric field due to this one. We have taken vertical component and we integrated that one. Horizontal component will get cancelled by the other elements. So that's the idea we have taken. And do that one. Usually follow that method if it appears. But I need this method also. Is that okay? So both will give the same integral. Last answer will be same. We can just check it out. Is that okay? Their elementary charge was a very small patch of area. Your dA will be r dr d theta. This r dr will be here. Look at here. Is that okay? Due to your cos theta and all, something else will come so that your denominator will be this one. Is that okay? You can just do that one. Is that okay? Small difference. So here I have taken this patch of area as a elementary. Here I have taken whole ring as elementary. Here I have taken this one as a dq. Charge on this one as a dq. Here I have taken total charge on the ring as dq. That's the small difference. Is that okay? And I am using ring answer here directly. I don't have to take any component. Am I right? So here I have to take component. I have to argue horizontal component vanishes, vertical component added, like that, isn't it? Now all of this ring will give Z cap electric field only. You can just integrate that one by keeping Z cap outside. Yeah, the question. Yeah. Now, I need these ideas, okay? Again, go back today itself to your density of state problem. So we have done that one, okay? We have done that one somewhere in our K space. We have done this one. We have taken this kind of, what you call, a region K plus dk, am I right? Number of states in the 2 dimension, whose wave vector is such a way that k running from k to k plus dk, am I right? So that is again this area is multiplied. This area is multiplied. So 2 pi k into dk. That's what I have written. And there also I use coordinate geometry to argue that one. Just check that out. Okay. I use coordinate geometry. I integrated with respect to theta. I have taken r k dk d theta integrated with respect to theta. So what would happen? 2 pi k dk. Is that okay? Here also r dr d theta integrate with respect to theta. You will get a ring. Am I right? That is 2 pi r into dr, like that. Is that okay? Just think over it, that coordinate geometry. Have a hold on that one. Now next I will go to, again problem is little lengthy, that conical problem. Before going to that cone problem, we better to go for 2.27, am I right? 2.27 or 27. So before going to 2.27, I'll start with a ring again. Ring, disc and then cylinder. That's the best idea. What is the potential at a distance z due to a ring of radius r? What is the potential at a distance z above the center of the ring, above the center of the ring, which contains line charge density lambda? Is that okay? So now you have to take dq, which is equal to lambda into dl, isn't it? Then this is italic r. So potential is equal to 1 by 4 pi epsilon naught. No component, nothing, am I right? Just integration of dq by italic r. So 1 by 4 pi epsilon naught. Italic r is constant, am I right? When you run that dq, that italic r, that magnitude, that's constant, am I right? What is that one? Italic r 1 by root of z square plus r square dq lambda dl, integral of dl 2 pi r, isn't it? Integral of dq, or integral of dq is the total charge on that one. That's also true, isn't it? This is the total charge, isn't it? This is the potential. This is the potential. Is it okay? At z, at a distance z due to a ring. Now go to disk. Exactly same manner. Exactly same manner. Then you can go for cylinder. I mean, for cylinder problem, this is the best way, because you can avoid that. Again, I tried in the morning, am I right? Doing that problem in a coordinate geometry. Coordinate geometry would be lengthy. You better to do it in this way. Okay? Same idea. This is dr, ring of radius r. Is that okay? Potential at a distance z. Now let me write this one as dv. Now this is elementary for a whole disk. Disk of radius capital R. Am I right? Let me take disk of radius capital R, because later he has taken cylinder of radius capital R. I have to extend the disk now. Is that okay? Disk of radius capital R. Now dv, again total charge on this elementary part of the disk, that is dq, okay? So that idea remains same. dq will be equal to sigma into 2 pi r dr. That idea remains same. Okay, 2 pi r dr is the surface area of the ring of radius r, thickness dr. Okay, thickness Ti. Yeah, any question? No, I mean we are not taking pi r square because it is actually integral 2 pi r r dr d theta. It is integral with respect to theta. That's what I am saying. In a plane, again, how did you define your patch of area? Any idea? This is d theta. This is theta. This is dr. This is r. Am I right? This was r dr d theta. Or r d theta into dr, like that. Am I right? This area. So now you have to extend this one like this by keeping r constant. Then what you have to do? You have to integrate with respect to theta, isn't it? If this area is r dr d theta, if you integrate with respect to theta, what would happen? It will be extended. Is that okay? So that's what you have written directly. That idea I have written directly. Don't write it as pi r square like that, subtraction or something. Okay? Don't do like that. It's actually this one. Whatever we are doing is actually this one, isn't it? Suppose if you have integrated r also, then you will get total area of the disk. Am I right? So that's how it works, isn't it? If you integrate r also, then you will get total area. You are integrating only theta. That means you are getting area of this circular patch. Is that okay? So now look at here. This contains charge dq. dq is equal to sigma 2 pi r dr. So 1 by 4 phi epsilon naught. In place of total charge of this is total charge of the ring. Am I right? In place of total charge of the ring, let me write dq divided by root of z square plus r square. Is that okay? 1 by 4 phi epsilon naught. What is that dq? Sigma into 2 pi r dr divided by root of z square plus r square. Integrate with respect to r running from 0 to capital R. Yeah, I need that integral now to find the answer. Quickly do that one. Okay, this was total charge on the ring, remember, 1 by 4 phi epsilon naught. Now ring is elementary, that's why I have written total charge on the ring as dq. So q by root of z square plus r square, isn't it? In place of v, I have written dv because that is elementary over. That's a fraction. So in place of q, I put dq. Now I converted that one into sigma and dr using again that idea. Okay, so just find the potential sigma into sigma by 2 epsilon naught. Am I right? 2 phi 4 phi integral r dr divided by root of z square plus r square 0 to capital R. I need this answer. You have direct answer. Wait a second. Sigma root of z square plus r square. That's it. Somewhere 2 will come. 2 should balance. Okay. It will balance out. Am I right? 0 to r. Just check it out. Okay. Later. Sigma by 2 epsilon naught. What is this one? Upper limit. Root of z square minus r square minus z. Due to disk of radius capital R. Isn't it? Now I have to use this answer to find the potential due to cylinder. Am I right? Solid cylinder. Now look at here how I am going to extend. I extended that lambda 2 pi r to sigma 2 pi r dr. Am I right? That's how I just manipulated. Am I right? It was a line charge, total line charge. I related that one to surface charge. Now I need to relate that one to volume charge because cylinder will have volume charge. Am I right? So now, help me to design the problem here. Suppose middle is the coordinate center. Can I take like that? Center of the coordinate is like this. Is that okay? Or how do you start? He said at a distance z above, am I right, that z should be, this is L, total length is L, that z should be greater than L by 2. This is L by 2. This distance should be z, that's what he said. This surface. This is z. That's what he has taken. If it is z minus L by 2, this should be z. Okay, let me take this one as 0. If this is z minus L by 2, yeah, that's correct. Then this should be z, am I right? This is L by 2. Then what is this one? What is this one? Minus L by 2 along z axis. Minus L by 2. Yeah, wait a second. I'm feeling something different here. Wait a second. This is minus L by 2. You have to integrate from minus L by 2 to z minus L by 2. Am I right? This is z minus L by 2. Isn't it? Wait a second. We shall take one elementary one. We shall take one elementary disk here. Okay. Shall take one elementary disk here. We better to do lower side, upper side separately. Okay. Otherwise, we may do some mistake. Okay. Now, this is of radius capital R. Okay. No need to worry. Now, that answer, I am going to write it as dV. Again, the problem is, you have to write this one in terms of total charge. What is the total charge? Sigma into pi r square. Sigma into pi r square. So, 1 by pi r square, 2 epsilon naught, sigma pi r square into root of z square minus r square minus z. 1 by 2 pi epsilon naught, 1 by r square. So, root of z square minus r square minus z into q. Can I write like that? Sigma pi r square is total charge on the disk. Because I need total charge on the disk. Now that total charge is elementary here. Isn't it? Now, so in place of that one, I have to write dV equal to, because now disk is elementary for a whole cylinder, solid cylinder, dV is equal to 1 by 2 phi epsilon naught, 1 by r square. So, root of z square minus r square plus r square. Z square plus r square minus z dq. What is dq? dq is the total charge on this disk. Am I right? Now that dq, you have to assume it is of width dz. Is that okay? Then what is the volume? Again, this contains total volume charge rho. This whole thing contains, so charge density, volume charge density rho. Is that okay? So now dq should be equal to rho into d tau. What is d tau? Volume of this disk. Is that okay? Rho into what is the volume of the disk? Pi r square into, that's how that dz comes. Because you need to integrate with respect to z ultimately. Isn't it? So now elementary, what you call potential, elementary potential is equal to 1 by 2 pi epsilon naught. Now look at here, potential will get add, okay? From here to here, potential will get add. That's why I'm feeling somewhere we may do some mistake. That's what I feel. Yeah, be careful. Z square plus r square minus z. What is dq? Rho pi r square dz. I think this got cancelled. Rho by 2 epsilon naught root of z square minus r square minus z. And you have to integrate with respect to z from where to where. Somewhere I am feeling something odd. Z running from minus L by 2. He said this is Z, am I right? No. The problem is, he said it is Z. Whatever Z he said, you have to be able to take it as Z naught. Because here our Z is variable. Are you getting my point? Your ultimate answer should be in terms of Z naught. Let me take Z naught. According to him, I mean, you have to find that one, I mean, at a distance Z naught from the center. Am I right? That's what he said. That's the question. Right? Z naught from the center. Let me take it as Z naught because now Z is variable. We may get confusion with that Z. Is that okay? Now if it is Z naught, what is this one? Z naught minus L by 2. No, somewhere we did some mistake. I'm choosing that origin. I'm thinking of that origin. That is the mistake. Plus L by 2, because you have to refer to that point, isn't it? You are finding the potential at this point. I'm always thinking about the origin. That's what I did the mistake. So from the beginning, again, I haven't put the limit, but I was very tempting to put the limit by thinking at the origin. No, origin is not the thing. You have to treat this one as the point. You have to find the distance of the disk from this point. Am I right? What is this Z? What is this Z? Distance of the disk from the point. Am I right? So in our earlier answer, Z was this one. Am I right? Now this disk, this elementary disk is at a distance, some arbitrary Z. Let me take this Z. This is as Z. And this is dz. Is that okay? Now this Z will run from Z minus L by 2 to Z naught minus L by 2. This is Z naught. Z naught plus L by 2. Let me draw it again. Okay. Yeah, I should not have written that center. That was not needed. Okay. Center of that one is not needed. Suppose somewhere here you have a center. I mean, so this is at a distance Z naught. Let me take from the center. Okay. From the center of the cylinder at a distance Z naught, you have to find the potential at this point. You have to find potential at this point. Let me take that point as Z naught. That's better because I have already taken this one as dz. Now let me choose this one as the origin or whatever. Okay, you have to integrate with respect to Z. That's it. Now you need this distance. Am I right? Suppose let me take this distance as Z. Again, I have drawn both in the same center. Wait a second. Notations. Okay. So now this is the center. From this center, he said, find the potential at Z naught. Am I right? From the center of the cylinder, isn't it? Suppose this is at a distance Z. Let me take this is variable Z, and this is dz. This is variable Z, dz. Now look at here. This Z should run from, what is this distance? Z naught minus L by 2, because this total, this is L by 2. Other one is L by 2. Again, this Z should run from Z naught minus L by 2 to, so this is Z naught. This is Z naught plus L by 2. Okay, this is Z naught plus L by 2. So that's why your potential, so rho by 2 epsilon naught integral of Z minus L by 2 to Z plus L by 2 root of Z square minus R square minus Z dz. Check it out. You have solution manual. No. Here, whenever you write, you have written a disk and you have written a potential for a disk at a distance z, isn't it? When you come to this problem, this distance is variable. That's where we made the mistake. The distance is variable. You are chopping it as a different disk, am I right? Are you getting my point? From ring to disk, that z was not variable. So now look at here, that this z was variable. This is the point of interest. This is the field point, isn't it? Now z was variable. Can you think of it? Isn't it? Potential due to disk. Now you are just sliding this disk here. So this distance from the disk from this point is variable now. So that is the difference from the earlier. Yeah, now ask the question. You ask something. Why can't we take this one as the origin or somewhere here, am I right? Wherever you take the origin, what you have to integrate? You have to integrate with respect to z only, am I right? Or you have to integrate with respect to distance from the disk, that's it. Because distance from the disk is variable. When you just move this disk from here to here, isn't it? We were finding potential at this point. Is that okay? Now, when you move this disk, it will make a cylinder. Now that is variable. That was not there earlier. Z was constant. From ring to disk, Z was constant. Only R was variable. So that's why the change. Is that okay? Yeah. Is that correct? Last integral? And do that integral. Try to match your answer. Yeah. Again, why that minus is coming? Yeah, is that okay? Wait a second, one more problem. Speak out quickly. Or let me do it like this. The distance from the center of the disk to the point of interest, isn't it? Now I have taken the same thing. Z is the distance from the center of the disk to the point of interest. This is the point. Now look at the diagram. This z should be variable. Is it okay? I have taken this dz with respect to dz. Now if this point is here, if this is z0 minus L by 2, it is z0 plus L by 2. That's what he mentioned. Okay, he mentioned find the potential at the point z, from the center, where z should be greater than L by 2. That's what he said like that. Okay, read question again. He said, find the potential at a distance z from the center of the cylinder, and that z should be greater than L by 2. And I have taken that z as z0 because I had one more z variable here. Whatever z he has given, I have taken that one as z0 to avoid the confusion. Is that okay? So now look at the variable. Now look at it. This is the variable. I have taken it as z. Now you can choose your origin here, suppose. You can choose your origin here. Whether you choose origin there or not, it doesn't matter. This distance is variable. That's what I am saying. Now this distance should run from z minus L by 2 to z plus L by 2. Is that okay? So if you choose origin somewhere else, that's not the distance from the point of interest, isn't it? Yeah, be careful. Okay, be careful. Do that one again. Yeah. Again, that's what I was trying to say. Is that okay? Now this Z is variable. This Z is variable. Isn't it? That's what we have taken, Z. And that's what we have written in terms of Z. And this Z, this distance should vary from Z0 minus L by 2 to Z0 plus L by 2. Isn't it? Then you have to choose this one as the origin. Isn't it? Point which is not variable should be origin. Always. But you can take this one as the origin. So this one as Z cap. And you need potential at this point. Isn't it? Potential at this point is due to potential due to all of these cylinders, all of these disks. Those disks are have the variable Z, isn't it? That's why you have to integrate with respect to Z. That's how dz also comes automatically. Yeah. I think that's what I was also thinking, whether you are saying plus L by 2 minus L by 2. Okay, Z0. Yeah, if it is ulta, one more negative sign is going to play the role, isn't it? Yeah, I thought that one, I was expecting. Yeah. Why can't you integrate from above to below? Both integration will not give the same answer, am I right? Integral a to b is always integral minus b to b. Something is missing. But he has also taken like that, am I right? I think. Why it is otherwise? dz. No, dz should be increasing. Dz should not be negative. Similar question will come again and again. So yesterday somebody asked that question in the that line integral of the electric field problem. Even though we are moving what you call opposite to the electric field in our line charge, that kind of problem, we will take E dot dl positive. Just check it out. Go back and check it out. Is that okay? If you are integrating, you have to make that dz positive. Are you getting my point? When you are moving from here to here, your z is decreasing, am I right? When z decreasing, dz, change in z will be negative. When you move from here to here, dz will be positive. Or you can put mod dz. This problem will come again. Okay, let me try to explain. We need some experience here. Isn't it? So again, my argument is when you are moving disk from here to here, z plus L by 2 to z minus L by 2, your z is decreasing. If z decreases, dz is a kind of z later minus z initial, z after minus z initial. That will be negative usually. Yeah. So the same thing happened yesterday. You haven't observed. Somebody asked that question actually. Where? Suppose we had a we had a line charge, we had electric field like this, isn't it? No, not this problem. We had a solid sphere of total charge Q, we wanted to find potential outside. Suppose if you are going from infinity to this point, you are coming from infinity to this point, radially inward. That's also possible, am I right? That's also one of the path, and line integral should be independent of the path. Now look at here, your integral infinity to r, E bar dot dl bar, electric field is radially outward, dl is radially inward. Why not one more negative sign? Isn't it? That was the question. Try to answer. V at r, we did like that. We found the answer. Now the question is, Yeah, what I have done, I haven't talked about that one at all. What I have done, I have written electric field in polar coordinate, dl vector in polar coordinate. I just taken dot product. I haven't thought it out. Isn't it? That's what we have done yesterday. Isn't it? Electric field outside, we have written as 1 by 4 pi epsilon naught q divided by r square r cap. Am I right? dl vector dr r cap plus and so on. I have taken dot product. I haven't thought of it, the direction between them. Suppose if you are talking about this dot product, you should have got negative sign. Isn't it? One more negative sign. Then in that one, when you take dot product, what is this? This dl should be now dr. Am I right? You are coming radially means that dl should be dr. That dr will be negative because that is decreasing. It will compensate that. The same thing will happen here. Okay, the same thing will happen here. Somewhere we were following all the rules of calculus. Am I right? Somewhere something is missing. Okay, we are following all the rules of calculus. Is that okay? No, this is by definition. This negative sign. I am saying one more negative sign because electric field and your dl. You are coming from infinity. Why can't you come radially inward? Isn't it? No, this negative is by definition. I am not saying that one. If you put one more negative sign because of this dot product, you will end up with one more extra negative sign. That's what I am saying. Yeah, that's okay. But if you are not writing these two, just think of electric field and dl vector. You know, electric field is radially outward. Now come radially inward. dl vector will be opposite to that one, definitely. Isn't it? dl vector will be opposite to that one. Now this dl vector, yeah, that may be minus r cap. That's correct. But dr into minus r cap, am I right? That dr is also negative. That's what I am arguing. Because radius is decreasing. What do you mean by dr dx? Final minus initial. Am I right? Final is small, initial is larger when it decreases. Okay, the same thing will happen here. Okay, so try to get this one. You need some more practice. I mean, little conceptual. Yeah, the question. What? Again, I am running out of time. Can you try that cone problem? A part of that one is little difficult. One part is very easy. Okay, so try that cone problem that is left. So if you are preparing for JEST exam, solve all of these problems. Okay, this kind of thing, that cone problem, all of them. Okay, they are asking that kind of problem. And at the end of the chapter, that two infinite wire parallel to x-axis, y-axis, like that. Okay. Try to solve that one. Let me explain. That's also purely geometrical. That problem is also purely geometrical. And we have an image problem in the next chapter just related to this problem. Okay. That's why you need that answer of this one in the next chapter. So try to solve that one. So tomorrow let me discuss theory. Again, any problem remain, let me solve later. Okay. Yeah. Question. That may include the space between point and upper surface of the cylinder. Not getting. So you haven't found the track of the comment. Yeah, why not? This is the first limit. Okay, Z. Yeah, that should be Z naught. That's correct. Z naught. I missed that one. So again, I had taken this this variable also Z, because there we put Z, isn't it? This Z was variable. So that's why I went back and I redefined his Z. That is Z naught. Okay. So that's why z0 minus L by 2, z0 plus L by 2, not z. Okay, integral with respect to dz. Okay, that's correct. Wait a second. Direction of dz. Yeah, this z cap. Yeah, above to below. But remember, how did you define z? Now, when you move from above to below, the z is increasing. dz will be positive. dz will be positive. That's how you do actually integration technique. I mean, very basic definition. What you do over there is, you are going to take z2 minus z1. Then you put that, I mean, final point minus initial point. Then you put that limit small. When you do that, when z is increasing, that dz will be positive. That's what I am saying. The same problem appears over there. Okay. That's why if you integrate from z0 minus L by 2 to z0 plus L by 2 in the increasing value of z, then you don't have to take dz negative again. dz will not introduce any more sign. That's what I am saying. Or I better to start with any integration basic definition. What we do here is dz, or suppose you are finding the volume. We are going to put dz or z2 minus z1 into this area like that. Like that you are going to add, am I right? If you come from here to there, each of those things will introduce negative sign, am I right? Final minus initial. That's how if you keep on doing, each of those things will introduce negative sign. That's why you have to take one more negative sign to make it positive. Ultimate thing is your volume, am I right? So try to think of volume, how volume integral works, just in the same way. Okay, dz means final point minus initial point, and that limit should tend to 0. Okay, that is the idea. The same thing will happen over there. Okay, so think over it.